Hi guys, in the previous video and activity we learned how to find the special angles on the unit circle, such as the 30-degree, the 45-degree, the 60-degree angles. And actually let me write them the way usually mathematicians write them, and I like black to use for this, so it's better to see. So 30, 60, 45-degree angles, right? These are written in degrees, and we found out how to find these in the unit circle, and we also learned how to do that in radians. So we know that 30 degrees fits 6 times into 180 degrees. That's why 30 degrees is really pi over 6. And we know that 60 degrees fits 3 times inside 180. Therefore, 60 degrees is really pi over 3. And 45 degrees fits 2 times in pi, so in 180, so it's pi over, 4 times. 45 degrees fits 4 times inside 500 and 180. I'm losing my mind. I'm not really making sense. Okay, so 45 degrees fits 4 times inside 180 degrees. Therefore, 45 degrees is pi over 4 radians. Also, I mentioned that those are special angles. The reason we call them special angles is because we can find their sine values without a calculator. And I know that Helen taught you how to do that. You're gonna say, whoa, this was such a long time ago. I don't remember really how we did it. You got some funny answers like sine of 30 or sine of 60, something like square root of 3 over 2, or sine of 45 is square root of 2 over 2, etc. Okay? We're gonna remember how to do this. In this specific video, we're not going to be finding sine of 30 or sine of pi over 6, but what we will do is we are going to learn how to find the sides in a right triangle which has those special angles in them. So again, in this video, we're going to look at special, I can't write, special right triangles, and we're going to figure out, and those triangles have a hypotenuse equal to 1, and they have those 30, 60, 45 degree angles in them, and we're going to figure out how to find their sides, how to find their sides. If we know the sides, if we know the legs of those right triangles, right? If we know their legs, then we can find sine of their angles, because sine is simply the opposite side over the hypotenuse, right? It's going to be equal to the leg over the hypotenuse. We're not going to do this part in this video. This is what you're going to do on the next page of your activity guide. Today, we're just going to figure out how to find those sides. So I'm going to draw two triangles, two special triangles. The first one has 45, this is ugly. The first one has 45 degrees angles, two 45 degrees angles, and a 90 degree angle. So if this is 45 and this is 45, or if this is, we can also say pi over 4, and this is pi over 4, okay? Then that means that those two sides are equal. Let's give some names to those sides. Let this be N, M, L. Okay. I also know that the hypotenuse is equal to 1. I said that the hypotenuse here is equal to 1. Now the question is, what are these sides? How big are they? Okay, here's what we're gonna do. We're gonna go back to our favorite Pythagorean theorem. Okay? If you remember, by the Pythagorean theorem, the leg squared plus the other leg squared equals the hypotenuse squared. Or you may say A squared plus B squared equals C squared. People use they define the Pythagorean theorem different ways. You can use whichever way is you remember it or the way you learned it. So in this case, our legs are equal to x. So we have x squared plus x squared equals hypotenuse, which is 1 squared. So this over here, I can combine like terms. I get 2x squared equals 1. I divide both sides by 2 because I want x by itself. And I get x squared equals 1/2. Now, to get rid of the 2 over here, the exponent, I have to do the opposite of exponents, which is square root. So I'm going to take the square root of both sides. I get an x is equal to square root of 1 over square root of 2. Now, square root of 1 is really equal to 1, and square root of 2 just stays square root of 2. Helen may have told you that mathematicians do not like to see square roots, okay, square roots like this one in a denominator. So instead what we're going to do is we have to get rid of the square root, but we really don't want to change the answer. So I'm going to take 1 over square root of 2, and what I'm going to do is I'm going to multiply it here. I'm going to multiply the denominator by square root of 2, but I'm now changing the fraction so that I don't change it. I'm also going to multiply the top. Why can I do that? Because I can easily just cancel these two and I'm back to my old answer. However, I don't want to cancel them. Instead, what I want to do is multiply those two fractions. I get square root of 2 on top, and I got square root of 4 on the bottom, which in reality is really equal to 2. So here's where those weird answers you got with Helen, right? Here's where they come from. They come from simply the Pythagorean theorem. So pretty much we took this special triangle with 45-degree angles and a right angle, a hypotenuse of 1, and we found out that both sides are equal to square root of 2 over 2. Both legs of this right triangle are equal to square root of 2 over 2. Now we're going to do the same. However, this time we're going to do it with a 30, 60, 90 degree, not 90 triangle. Okay? So here's how this works. We need one more picture. This time, I don't want the sides to be equal. What I really have over here is, let's erase this part. It's just not good. Okay, cool. Now, what we have over here is A, B, and C. This is the right angle. This is the bigger angle, so we will say this is 60 degrees. I don't know what happened to my screen, but it's not cool. Let me fix it. I don't want symmetry. Okay, that's better. And 30, this has to be a 30-degree angle because all of the angles have to add up to 180. So 60 plus 30 is 90 plus 90, 180. Okay, well, how am I going to find the sides if the hypotenuse is equal to 1? These are not equal. It becomes a little more complicated. I have to take this side CA and I have to extend it the same length and draw a triangle. You may notice right away, let's give it a letter. This will be the letter D. You may notice right away the triangle ABC is actually congruent. It's exactly the same as triangle ABD. They're exactly the same. They have these two sides are equal. The angle, both angles are 90 degrees, and this side is equal. So if you remember the postulates for congruent angles, we have a side angle side postulate, which tells us those two are exactly the same. Oh, great! If they're equal, if these are congruent, if ABC is congruent to ABD, Therefore, all of their sides are equal. So CB is equal to BD is equal to 1. And this angle over here is 30 degrees. And this angle over here is 60 degrees. Oh my God. This is 60, this is 60, and this angle here is also 60. When we have three angles equal to 60 in a triangle, this triangle is equilateral. Equilateral means that its sides are all equal. Therefore, this side over here is also equal to 1. Oh, great. And I know that these two parts are also equal, so therefore, this half of this one is just 1/2, right? This side AC is half of CD. AC is equal to 1/2 of CD, but if CD is equal to 1, then AC is simply 1/2. Good, I already found one side. I found that AC is equal to 1/2. Now I have to find AB. Well, to find AB, I'm just going to go back to the Pythagorean theorem. I'm going to say 1/2 squared plus, and let's call this x over here because I don't know it, plus x squared equals 1 squared. So what I get is 1 over 4 plus x squared equals to 1. I want to move 1/4 to the other side, so I'm going to minus it on both sides. I'm going to do minus 1/4 minus 1/4. Those 1/4s are going to cancel out. And what I get is x squared is equal to 1 minus 1/4. Well, guess what? If you do this as if we subtract those two fractions, I put a 1 on the bottom. I need to make the denominators equal, so I'm going to multiply here by 4 and here by 4. And what I really get now is 4 over 4 minus 1 over 4, or x squared is equal to 3 over 4. I'm going to follow the same step over here. I need to get rid of the exponent, so I'm using square root. X is equal to square root of 3 over square root of 4. Well, square root of 4 is really just 2. So it turns out this side over here, AB, is equal to square root of 3 over 2. Again, AC is equal to 1/2, and AB is equal to square root of 3 over 2. Now follow those same steps. Make sure you include all the math in your activity guide. Thanks.